Assalamu alaikum warahmatullah. Welcome to another class of mathematical solution of Pascal's law, and this is part 3. So in this tutorial I'm just going to show you this type of question which is common in English versions O-level and Cadet college students questions. So hopefully this sort of similar questions I explained in my previous video in a different way, but you see here some sort of similarities you can imagine. That this is the mathematical problem solved on Pascal's law, and we know that what is Pascal's law. When we'll try to solve the mathematical problems, at first we need to know the theory and of course Pascal's law and the Archimedes law. Things should be very clear. And you see the question number 1. Suppose there is something that is immersed into the water and it's given. Now you think that the area of the object, that is ABCD, is a rectangular object which is immersed into the water as said, but this liquid can be anything. But this is water. If said, then we must know that the density of water in 4 degrees Celsius is 1000 kilogram per meter cube. We know it. So that is the data which is already known. The density of water in 4 degrees Celsius is 1000 kilogram per meter cube. Now you think we need to find out the buoyancy felt by this object, and what we know that if it is a buoyancy is a force, we can say that V rho G. So this V is the volume of this object, this rho is the density of this liquid, and this G is the acceleration due to gravity. We know it. So we know the value of G is 9.8 meter per second square, and the rho is 1000 is just given. Though if it is not given in the questions, we know that the density of water is 1000 kilogram per meter cube. Now we need to find out the volume of this object. Think about it. Area is already given, and we see that some sort of hints also given, that this is the height from the upper surface to the lower surface of the object, from the upper surface of water till the lower surface of the object, and the upper surface of water to the upper surface of the subject or object is given, which is 30 centimeter. So we can have the idea of the height of the object, and that is actually the height of the object should be, this is total 90 centimeter. So, and this is 30 centimeters. So the height is actually this one. So this should be 60 centimeter. So 90 minus 30 is 60 centimeter. We need to take it as a meter. So it should be 0.6 meter. Fine. Now we think V is what? V is the area times height, then rho and G. Now you think A is given 800 centimeters square. Now another one thing, that area is 800 centimeters square. Now we need to make it meter square. So what we need to do? We need to do it 10 to the power minus 4 meter square. As in my previous class, I showed how to convert this centimeter square to meter square. And this is very basic mathematical knowledge, and that should be done accurately. And you see there are two zeros, that means 8 times 10 square times 10 to the power minus 4 meter square, which is actually 8 into 10 to the power minus 2 meter square. So it's given. So we have area. So that is 8 into 10 to the power minus 2 meter square times this meter, that is meter cube, into rho is 1000 into G is 9.8. Now you got the buoyancy, and this is actually the buoyancy. This buoyancy. Okay, now we need to find out the calculation. So 8 times 10 to the power minus 2, which is actually 0.08 times 0.6 times 0.6 times 1000 times 9.8, which is 470.4 Newton. This is the buoyancy. This is easy type of questions. I agree, but some of you, I need to know that those are viewers of this video. Will it feel you like is easiest or something like, because I'm just uploading this video for the first time, those who will be solving these questions, but there are some critical type of questions also that we need to solve based on the demand of your viewers. So those who are watching this video, do let me know in the comment sections that your feelings. And then second question, if the object, this one, is left free in the water, will it emerge or float? This is actually Archimedes law, and I uploaded this sort of similar things in my previous videos, that whenever we need to think that will it emerge or will it float in the water or in liquid, we need to think in a different way about the density or the buoyancy. So first questions like this, we need to find V, rho g is given, so simple, Newton done. Now if we think clearly that, okay, this should be done, okay. Now you think about that one. This is another object where diameter is given and height is given. The diameter, as it looks like cylindrical, the diameter is 6 centimeter. So as diameter is 6 centimeter, so we know that radius would be half of the diameter, that is 3 centimeter, and that should be 0.03 meter. And you see height is given 3 centimeter. Now what we need to know? We need to know the volume of the object, because it's all about that floating or emerging things that we need to find out the V. And as this is cylindrical, it should be pi r square h, volume. Now we think pi means 3.1416, r 0.03 square, h means 3 centimeter, that is 0.03. So okay, then we need another calculator, and we see that 3.1416 times 0.03 square times 0.03, it's altogether cube, so it would be 8.48. So that is 8.48 times 10 to the power minus 5 meter cube. So you got the volume of the object. Now one thing, the mass is given of the object, which is 100 gram. So we need to think as a kilogram, this is 0.1 kilogram. Now what I said earlier, that will it float or sink into the liquid as it is water, we need to think about the density first. So if we need to find out the density, then what we need? We need rho equal m by v. So as we have m, which is 0.1 kilogram, the v I just got it, 8.48 times 10 to the power minus 5. So we see that what is the value of density. So if we say that 0.1 divided by 8.48 times minus 5 is something like 1179.24, that is kilogram per meter cube. Now you see the density of the object, density of the P object, the density of P object is greater than the density of water. It means, because we know that the density of water is 1000 kilogram per meter cube, but you see the density of this P object is more than water, that means it will sink into the water. But, or if we see that if we, will it float, or in this case we can think in another way, that the buoyancy. So at first we have understanding that okay, if you give the answer that okay, it will immerse into the water, it will sink into the water because the density of this object is higher than the density of water, that is okay. But if we can think in another way, what is this? As we have the mass of the object, we can have the weight of the object. So we can say weight is W equal mg. Now you think about mg. So m is 0.1 times 9.8, which is 0.98 Newton, is the weight of the object. Now you think, what is the buoyancy of the object? If it is just let it fill it into the water, then the buoyancy F would be V rho G. Now you think the V of the object, that is this 8.48 10 to the power minus 5 times this rho is the density of the liquid, which is 1000, and G is 9.8. So if we do it, this 1000 means 10 to the power minus 5, so it would be 8.48 10 to the power minus 2 times 9.8, and let's see what would be the answer. 8.48 times 10 to the power minus 2 into 9.8, that is 0.83 Newton. Again we can see that this is also true, that the weight of the object is greater than the buoyancy, 0.83. So as 0.96 and 0.83, as the weight of the object is greater, then it means it will again sink into the water, or it will immerse fully into the water. So both cases answer is right. In the previous way, that we can say that this is actually the same, the density of the object is greater than the density of water. Similarly here, the weight is also heavier than the buoyancy of the object when it will let it free into the water. So in both cases the answer are right, and you can definitely think in which way you should answer in your question paper. So I hope you understand the process. Well, of course, if you don't, then let me know, and if you understand, of course let me know, and just let me know in the comment sections of these videos that will it okay or not, or even you have any questions, then ask me in the comment section. I will try my level best to answer when I'm available in the net. So take care, stay well, stay blessed. Bye.